Welcome back, and we're going to continue our discussion on conversion factors and dimensional analysis. Only this time we're going to take a look at what happens if you have to do more than one conversion. And an example of that is this very first one, and how many minutes are in a day, in 1.4 days actually. And most people don't know the direct conversion from minutes to how many minutes are in one day. So we're going to have to go to a couple of them. So as we always do, we're going to start with what we're given. And you're given 1.4 days. And now we're going to work backwards. We're going to go to smaller. And the next conversion that you probably know is how many hours are in a day. And we have 24 hours in a day, so I'm going to set up my ratio. So I've got my conversion factor. I'm going to put my line there for my ratio. I want days in the denominator, and the reason I want days in the denominator is because I want to be able to cancel it out. And there are 24 hours in a day. If I were to stop right here, my answer would be in hours. And I want to continue on. And I want to know to go to minutes. Well, chances are you're familiar with how many minutes are in an hour. So I'm going to set up a second ratio. And in this ratio, I'm going to put the hours in the denominator this time. So in every 1 hour, we have 60 minutes. The hours cancel out. And the only unit remaining is the minutes. And so now I can calculate this. Okay, and we get 2100. So I have 2100 minutes are in the hour. All right, we take a look at this. I've got my unit, which is what I need. Let's check significant figures. These two are exact numbers. There's exactly 24 hours in a day. There's exactly 60 minutes in an hour. So I don't look to those two for significant figures. So we go over here. How many significant figures there are there? There's 2, which means I want 2 in my answer, and I have 2. The 2 and the 1 are significant. The zeros, what do we call those? Placeholders. That's right. All right, now below this is, is a little chart, and you're going to find this table. It's a link on the top section of the course, and it's basically comes out of your textbook. It's just the conversion factors for all these different metric prefixes. The metric prefixes they're just a really nice abbreviation. Now, what they're based on, these are based on is relative to the base unit. So in this case, the base unit is going to be a meter. And you'll see that a centimeter is 0.01 meters is equal to 1 centimeter. Conversely, there's going to be 1,000 meters in a kilometer. So now we want to go from kilometers into millimeters. Whenever you see this, where you have a prefix here, a metric prefix here, and another metric prefix, that's going to require 2 conversions. So we're going to start with what we're given, and we're given the 0.225 kilometers. All right, so we're going to set up our ratio like so. Kilometers is going to go down here. And according to this chart, there are 1,000 meters. There's 1,000 meters in 1 kilometer. And that sort of makes sense because remember, a kilometer is a little more than a half of a mile. So kilometers are going to be really large. If I were to stop right now, my answer would be in meters, but I don't want to be in meters. I want to be in millimeters. So the next thing I need to do is, let's get rid of the meters. I'm going to go from my base unit to the prefix milli. And in every 1 millimeter, there's 10 to the minus third meters. Notice that the meters cancel out, the kilometers cancel out as well. And you'll see that right there, there's 10 to the minus third meters is 1 millimeter, as opposed to the kilometer where there's 1,000 or 10 to the third meters in a kilometer. All right, so now we can multiply this out, and I'm going to get 2.25 times 10 to the 5th, and that will be in millimeters. There are lots of millimeters in a kilometer. Remember, milli is going to be small. Okay, take a moment and let's see if you can do the next one. Okay, so the question is, how many nanograms are in 2.25 centigrams? We're going to start with what we have, and we are given that we have 2.25 centigrams. And the very first thing that you do, since I'm going from one metric prefix to another, centi has a metric prefix, so is nano. So we take a look at this, and there is 10 to the minus second grams in a centigram. In 1 centigram, the centigram cancels out. And the next thing we need to do is we've converted it to the base unit. Now I want to get to the second metric prefix, which is a nanogram. So you take a look at nanogram, and you can see that there's 10 to the minus ninth nanograms, or grams, pardon me, in 1 nanogram. Notice that the ones, or the units with the metric prefix, they have a 1 in front of them. All right, so we're going to calculate this out. We throw this in our calculator, and we get 2.25 times 10 to the 7th nanograms. So there are 2.25 times 10 to the 7th nanograms in 2.25 centigrams. Okay, so the approach that you need to take whenever you're doing these problems is recognize what units need to be found. Always start with the given. Multiply given by fractions so that the units cancel. Round to the correct number of significant figures. And this part right here is super important. Anytime you have an assignment where you have a text box, so these are not the computer graded assignments. The computer graded assignments, you cannot show your work. But anytime you're going to have a text box, you are going to be required to show all of your work for you to get credit. The answer is only going to be 1 point. Now, an example of showing work in the text box, because unfortunately you're not going to be able to do the fractions where it's the numerator directly on top of the denominator, but this right here would be an example of a perfect way to represent your work in doing these conversions. See you next time.